Hi, welcome to Unit 3, Day 1, Electromagnetic Radiation. This is Part 1, What is Light? So some things you probably already know about light. You probably know that white light is made up of different colors. You probably know that light is bright and it can feel hot. And you also know some natural sources of light. But what exactly is light? Light is known as electromagnetic radiation. And it's known as electromagnetic radiation because it is made of oscillating electric fields and magnetic fields. The electric field, which is shown here in blue, is oscillating in the X and Y plane, and the magnetic field, shown here in red, is oscillating in the perpendicular XZ plane. In addition to what light is made of, it's important to know that light has a dual nature. It behaves as a particle and a wave. And one way to sort of think of it is light is a particle that, as it travels, produces a wave. So how do scientists know that it has both a particle and a wave nature? In 1801, Thomas Young conducted what's known as a double slit experiment, which gave evidence of light's wave nature. So we're going to talk about this experiment, but before we do, it's important to know that the experiment shows radio waves like ripples on water, and we often use transverse waves. So here's an example of a radio wave. Again, looks like ripples on water. And the transverse wave is sort of like the side view of those ripples. So what did his experiment show? Essentially what he did was he shined light through slits, and the pattern that emerged from the slits, he did it in two separate slits, was sort of this band of brighter light and then sort of a darker band, so alternating bright and dark bands. And he concluded that this must be due to constructive and destructive interference. So constructive interference occurs when two waves sort of line up and their peaks line up together, and so the resulting peak is a larger peak. Destructive interference is sort of the opposite, where a peak and a trough will line up and they cancel each other out. And so the constructive gave the bright light, or the bright bands, and the destructive gave the dark bands, or the absence of light. And since waves can constructively and destructively interfere with one another, he concluded that light must behave as a wave. About 100 years later, Albert Einstein explained the phenomenon known as the photoelectric effect as due to the particle nature of light. So this is how we determined that light also has a particle nature. So let's talk about the photoelectric effect. For a long time, scientists knew that if you shined light on metal, particularly if the light was at a certain energy, electrons will be ejected from the surface of the metal. And that wouldn't occur if it was a wave, but it would occur if it's a particle. So if you can picture a light particle hitting an electron, which also is a particle, it sort of shoots off, sort of like playing when you play pool. So both of these experiments help us to understand both the wave nature and the particle nature of light. The last thing we're going to talk about in this part is the electromagnetic spectrum, which is something you've probably seen before, and essentially shows all the different forms of light. So it's important to know that there's more than just one type of light. And light is classified by both its wavelength and frequency. So we have radio waves, microwaves, infrared, visible light, which is the one we're most accustomed to, UV or ultraviolet, X-rays, and gamma rays. They're all forms of electromagnetic radiation. Let's summarize what we covered so far, and here's where you'll take your notes. Light is electromagnetic radiation. The electromagnetic spectrum shows different types of lights classified by their wavelength or frequency. Light has a dual nature, behaves as a particle, which is known as a photon, and a wave. And a photon, which we'll talk more about later, but we'll note it now, has a discrete amount of energy known as a quantum of energy. Okay, so there's a CFU following this section. Pause the video now, try the CFU, and when you press play again, the answer will be revealed. So the answer for the first CFU is true, and for the second, it's gamma rays. That's it for this video. Have a quality day.